Okay, so in the previous video, we made the two input adder that adds two inputs, each of 4 bits. Really, it can be n bits, so I'm just going to say n bits here, and this is of course a and b, and then it produces an output that has n plus 1 bits. So now the question becomes, well, can I use this to make a 4 input adder? Well, of course. What I would do is I would do the following. I would have 4 inputs. Two adders on each of the two, and then one final adder at the end. So here we have call it SA2N, and so of course I can say these are also N, and then my new inputs are going to be A, B, C, D, and then my output is going to be N plus 1 here. But this is also a 2-input adder, but luckily I made the input adder so I can change whatever type of input I need. So if I need, let's just label this here. So if I need my input, let's say this is 4, so then my output is going to be here. It's going to be 5 bits. So then my input is simply going to be, just 5. That's the n that I'm going to be passing along. And then my output is finally going to be n plus 2. So, but what if I want to take it even another step forward, right? So this design, I can call it, I'm going to call this design signed adder 4N. So then what I can do now is I can say, well, if I can do a 4-input adder, how about an 8-input adder? Well, I can exactly do that. I can have so let's, right here, 4 inputs. So now this is I'm instantiating this here, and then I have the same thing here repeated. Let's copy it down here. And then this is going to go into another adder. So this is simply going to be 2-input adder. So we're going to have actually, these are all n, and the output coming out through here is going to be n plus 2. So what we expect here is actually just n plus 3. This is what we expect to see. Okay, so let's go into ModelSim and let's start making these programs. Okay, so this is where we left off last time, and we want to create a 4-input adder. So we're going to be instantiating from this piece of code. So let's go ahead and add to the project, add a new file, browse, go source, select that folder, and then we're going to say signed adder 4-input, like that. So now what I want to do is I want to edit this. Okay, so I'm in my new file, my SA4-input. Now let's just write out what this would look like. And then once again, I want to pass a parameter. I'm going to call it M this time. I'm going to say it's 4. That's going to be the default value. So my input logic is still going to be 4 bits. So it's going to be n minus 1 to 0. But then I'm going to have 4 inputs. So that's going to be A, B, C, and D. And then my output logic is actually going to be larger this time around. So it's going to be n plus 1. And then I'm going to call it sum. Okay. So now I have some internal variables that I want to declare. I'm going to call it, these are going to be of size m. I want to call it out1 and out2. So now I'm going to perform my instantiations. So this is actually very straightforward. I can just say that. So I'm instantiating signed adder 2 input. And then I'm passing along m into n from the previous. So I'm going to call, and then I'm going to call this object adder 1. Input is going to be A and B, and then output is going to be output 1. And then similarly, just going to copy paste this. This is going to be output 2, or rather adder 2. And then we have B and D here. And then we have the output, it's going to be out 2. And then last but not least, we're going to instantiate one final adder. So let me copy this over. So if you remember, this adder needs to be, it's taking in bits that are 1 bit larger than n. So we need to make sure that we adjust for that. So we're going to put a +1 here. I'm going to give it a different name. And then we also know that our inputs that are going into this is going to be the outputs from the previous. So we're going to call it like that. And then last but not least, we can say sum. So then we come down here, we end the module. Like that. Okay, so I've got it to compile successfully. I had a little error here, but it's good now. So now what I want to do is I want to create a new file. I want to put it in my test bench. Call it SystemVerilog, and then I want to give it this name, SA or input underscore TB for test bench. I press OK. Now I double click it. So what I want to do here is I want to actually test out 4 inputs, and then obviously I want them to change as they go along. So I already made the test bench. I'm just going to show you what it looks like. Alright, so this is what the test bench looks like. I'm going to go ahead and press save, and then, so basically what we have here is we have these 4 binary inputs, and this is their starting position. And then they're going to stop, and then it's going to be incrementing each 4 of them. And then when the first one, meaning this one, reaches this value, it's going to stop. And then this flag is going to go up. At the same time, it's going to reset all of them to 0. So now this loop, this if statement is no longer going to loop here. It's going to loop through here because of the flag. And then it's going to keep looping here. It's going to be counting all by 1 at a time, starting at all 0. So let's go ahead and compile. All right. So I want to go to simulate for input test bench. Now we don't need to do thorough testing for this one because we know that our 2 input adder is working perfectly fine. So really here, this is just, to verify the operation. Oh, and then all of these need to be in decimal. So, okay, so there it is. So we see here 0 plus 1 is 1, and 2 plus 4, that's 6. So 6 plus 1, that's basically 7. So that works. Move along here, we see 2 and 8. So that's basically 11. 3 and 8, that's 11, right? So basically what I'm looking at is I'm looking at the sum of these 2 numbers, and then I'm looking at the sum of these 2. And then this output is basically the sum of the 2 sums. Or I guess it's the sum of all 4. It doesn't matter how you look at it. So this is all good. I trust that this works, so I'm not going to go through each and every one, but yeah, this is nice. So we see this -8 times 4. Another way of thinking about it, that's 32. And then -1 times 4, that's just -4. So now let's just take this a step further. because, you know, why not? Might as well while we're still here. I want to add another file here. This time I'm going to call it 8 input. It's going to be SystemVerilog. At the same time, I want to make a test bench. So let's make a test bench. Now let's put it in the TB file or the TB directory or folder or whatever. Let's call it underscore TB SystemVerilog. All right, so let's open the 8 input. All right, so remember this one has to have 8 inputs. So actually, if we start coding it, so it's going to be a SA 8 input, and then once again the parameter. I'm going to call it P this time. It's going to equal 4. No, this is a curly bracket. I want a regular parentheses. My input logic, once again, is going to be 4 bits long. So that's going to be P minus 1, 0. So this is going to be A, B, C, D, E, F, B, H. So this is 8. 1, 2, 3, 4. That's 8. And then the next thing we want to do is we want to declare our output. And then the output is going to be P plus 1. No, that's going to be P plus 2 actually. Because it's going to be 6. It's going to be 6 to 0, so that's a total of 7 bits. So yeah. All right, and then we close that. So now we say logic of P plus 1, that. So it's going to be P plus 1 through 0. So this is my interior variables. Out 2. How's that? And then I move on to the instantiation. So this time I want to instantiate the 4 input adders, right? And then I'm just going to call it adder 1. Let's see. So this is going to have, so the first one is going to have 4 inputs. So it's going to have A, B, and then the output is going to be out 1. Close that. So let's copy paste this over. We're going to call it adder 2. This is going to be E, F, G, H. Output is output 2. Oh, I don't know what that is. And last but not least, we want to instantiate 2 input adder. Right? So let's see if I can maybe make use of this. So here's the important part. We want to instantiate it with an additional bit as a parameter. And then finally, the output 1 and the output 2 of the previous adders are going to be considered the input for this one. And then we end module. Okay, so then let's see if this compiles. Okay, so it compiles. So now we move on to the test bench. Actually, I need to save it first. What am I thinking? So now we compile. Oh, this needs to be a capital. Is it capital? That's capital. Capital. Okay. Let's see if that does it. Okay, so that does it. Now, yeah, we do the test bench now. Once again, we're not really testing the adder. We're just showing proof of concept of instantiation. So this time we have a lot more to instantiate, or we're gonna have more interior variables. Well, actually, we're not gonna have a lot of interior variables. The only interior variables are out1 and out2. What I mean is we have a lot of inputs and outputs. Right? We have mostly inputs. We only have one output. But see this? We have 8 entire inputs, and each is going to be 4 bits long. So if we look here, we see that we set all of our inputs to a certain pattern, I guess. And then this if loop is going to be looping, and then it's going to stop when the first one reaches 1, 1, 1, 1. And then we're going to reset everything to 0, and then we're going to be counting all together from 0 to this value here, which is 15. So let's see. Let's compile all. So it all compiled nicely. So now let's go to simulate, start simulation. We go to the 8 input test bench. We run that. Looks like we have an error loading the design. What is this about? Oh yeah, we need to come back here. This is actually n, because n does pertain to the input of the 2 input adder. So we need to make that n. Now we finally save that. Let's see if we can finally, this should compile, no problem. Let's see if we can simulate. Okay, so I think that worked. Yeah. So now what we want to do is we want to look at the flag. We want to look at all of these inputs. We add that to the wave. Right click. We want it to display it in decimal. So we select decimal, and then we run it. So let's see what this looks like. So here it is. So we are adding all of these numbers, and then in the last number here is the addition of everything. So yeah, this works. So you can see that this goes as high as -50. So right here we have the 2 highest numbers, which is 56 and then -64. So, and -64 is represented by this here. So this is 1, and then followed by like, I think 6 zeros. Yeah. And then everything else seems to be working fine. So we've basically did what we set out to do. So now all that's left is that I actually want to look at what this circuit looks like in the RTL viewer. Okay, so I'm here in Quartus, and then I want to add these files that I just made. So if I go to my source files, I want to add the 4 input, and then I also want to add the 8 input adder. So then I want to apply, press OK. Let's see if I can pull it up. I would have to open it actually, like that. So then I press Control K. I believe I have to change the top level entity here. So now I can press Control K. Let's see. Okay, so that does it, and Quartus has generated the RTL viewer here. So let's go ahead and go full screen here. And as you can see, this is the 8 input adder. So we've instantiated 2 4 inputs, and then after the 4 inputs, we have instantiated the 1 2 input, and we can actually click inside of this. And this is actually what the 4-input adder looks like. If we look inside, and we see that we instantiated 2-input adders, so that's good. And if we click on any of these, we can actually see our original design. So there it is. And we click here, it's the same design. So I guess what we can do is we can compare this one. This is a 5-input. Okay, we can compare this one. This is a 4-input adder. So we see we have like about 5 logic gates here, this side. And if you look at this one, we also have 5. So not much difference. So anyways, that concludes this video. Thanks for watching.